We live in the age of great astronomic achievements. Over 5,000 distant worlds are known to us thanks to today's orbital telescopes. Most of those places are truly wonderful places, unique and mysterious, and sometimes extremely dangerous. There are planets out there illuminated by 2 or 3 stars at the same time, whereas others are eternally shrouded in the darkness of space. Some of these worlds inspire terror by their extreme conditions, while others make one marvel at their bizarre features. We have already been on a journey to the most terrifying planets before. It's time to move on to other objects. As a rule, it's potentially habitable planets with favorable conditions and a moderate climate that especially catch one's attention among the great diversity of other worlds out there. Or else, on the contrary, extremely dangerous objects stand out among others. Still, there is yet a third category. It's anomalous celestial objects manifesting unusual behavior which is barely scientifically accountable. Objects like that challenge our knowledge and deserve special attention. This is exactly the kind of world we'll be looking at now. 2009 year, the environs of the Kepler 413 system. An unknown object passes between our planet and the distant star, briefly reducing its luminosity. Astronomers take this event to be a standard exoplanet transit and announce the discovery of a new celestial body. However, 180 days later, another expected transit never occurred. High-precision calculations even make it possible to determine its parameters. The planet turns out to be a cool giant with a mass of about 25 times that of the Earth and a radius of about 40% that of Jupiter. The planet, so clearly visible in the old data, seemed to have vanished without a trace. A dark spot in the photosphere of the star or a giant dust cloud moving in its vicinity would have accounted for the mysterious phenomenon. But these hypotheses were dispelled when 800 days later the mysterious object reappeared just as suddenly as it had vanished. The hypothetical planet eclipsed the disk of its parent star 5 times before disappearing again. Still, the key to the riddle had been found. It turned out that Kepler 413b has a highly unusual orbit. The celestial body is located near a binary star and is 0.360 from the system's common mass center. Its trajectory is constantly affected by gravitational perturbations, and the changing gravitation of 2 nearby stars shifts the orbital plane considerably, causing cyclic oscillations. When the deviation reaches its maximum, the object leaves the line of vision and then returns to it. Calculations show that Kepler 413b's orbit oscillates with a periodicity of about 11 years, deviating 2.5 degrees in each direction from its average value. The planet's own axis of rotation also changes its position significantly, with a maximum angle of inclination of up to 30 degrees. Combined with the noticeable eccentricity of the orbit and its periodic shift, the climatic conditions on the surface change in a bizarre way. The region that receives the most light from the parent star is constantly shifting from the equator to the poles and back, which leads to dramatic variations in temperature. It is likely that this process generates huge planetary-scale hurricanes, which can be larger than the Great Red Spot of Jupiter. Air currents can carry ice clouds at several kilometers per second, gradually becoming unstable and dispersing. Meanwhile, the collision and deformation of vortices is capable of causing tremendous atmospheric emissions that have the power to overcome the planet's gravity and reach outer space. According to calculations, they will hang a while up there before gravitational forces pull them back down. All these incredible phenomena make the planet a rather harsh place. However, it may seem like a tranquil, serene island in comparison to the following world. 190 light-years from Earth, the environs of the HD 80606 system. This yellow dwarf, surprisingly similar in parameters to the Sun, is orbited by a planet with a highly variable climate. It whizzes towards its parent star as rapidly as a giant comet, burning itself in the hot rays of its corona, only to drift away to the periphery of the system. The object is a gas giant with a mass 4 times that of Jupiter and a radius slightly different from that of Jupiter. At the furthest point in its orbit, the planet is 0.880 away from the parent star and receives about as much heat from it as the Earth does from the Sun. It has been suggested that this is when clouds consisting of water vapor droplets, ice crystals, or even microparticles of quartz may condense in its atmosphere, and temperatures on the surface of the hypothetical satellites of the gas giant could be comparable to those on Earth. But as the planet gets closer to the star, conditions on it change very quickly. Within 55 days, the distance between them shrinks by a factor of nearly 30 and the energy flux from the star increases by a factor of 800. Observations show that, at the lowest point in its orbit, the exoplanet's temperature roughly doubles within a matter of just 6 hours, from 500 to 1,200 degrees. Such drastic changes result in violent hurricanes, which can reach speeds of up to 5 kilometers per second. By absorbing an incredible amount of heat, The atmosphere of the gas giant expands so fast that it produces shock waves capable of sweeping across the entire planet multiple times. Water vapor is broken down into oxygen and hydrogen by the temperature, and quartz crystals evaporate without a trace, only to recondense into gigantic sand clouds later. In all likelihood, HD 80606b is the only planet in its system. The gravity of another nearby star has not only warped its orbit but has also wreaked havoc on the protoplanetary disk, so the chances of encountering other large objects nearby are rather slim. However, destabilization of a planetary system due to the interaction of celestial bodies is not uncommon. 1,530 light-years from Earth, the environs of the Kepler-36 system. The central object in this system is the yellow subgiant. Its mass is comparable to that of the Sun, and its radius is 62% larger than that of our star. There are 2 planets rapidly orbiting the star, a rocky super-Earth and a hot mini-Neptune, every 97 days. They mutually approach at a critical distance of only 1.9 million km, about 20 times less than the minimum distance between the Earth and Venus. At such moments, their mutual attraction causes global cataclysms. But after a few days, the celestial bodies diverge again until the next resonance. According to calculations, the gravitational interaction between the planets at the point of closest approach is about 13 times higher than that between the Earth and the Moon. In particular, this effect should be seen on the surface of the rocky planet. Under the influence of titanic forces, its crust may crack and shift, causing earthquakes of incredible power. The resulting chasms may be hundreds of kilometers long and cause multiple eruptions of gigantic volcanoes. It is likely that some regions of the planet do not cool down in the short period of relative tranquility, creating seas of eternally bubbling red-hot magma. The reasons for the formation of such an unusual system are still debatable. We now know that the super-Earth, dubbed Kepler-36b, is 0.120 away from its parent star, and it takes 14 days to complete a full orbit around it. The super-Earth's mass is 3.8 times that of the Earth, and its radius is 1.5 times that of our planet. The object has been calculated to have a temperature of 980 Kelvin, or just over 700 degrees, and an average density of about 30% higher than that of the Earth. The data suggests that the celestial body could be a Chthonian planet, the core of a gas giant that has lost its atmosphere. Such objects contain many heavy metals like iron and lead, as well as sulfur and silicon compounds. It is likely that the light elements that once made up the thick, dense shell of the celestial body may have been blown into space by stellar wind. Nor should we forget the second planet's gravitational pull, which could potentially have contributed to this process. The object is called Kepler-36c and is likely to fall into the class of hot mini-Neptunes. The celestial body moves in a nearly circular orbit with a radius of 0.130 and completes it every 16 days. Its mass is 7 times that of our planet, and its radius is 3.7 times that of the Earth. Because of its proximity to the star, the temperature of the object is also very high, 928 Kelvin or 655 degrees. According to today's notions of the structure of exoplanets, this celestial body should be surrounded by a thick, multi-layered atmosphere consisting mainly of nitrogen, hydrogen, and helium. Deeper down, the pressure inside the gas shell increases, and it gradually turns into an ocean of supercritical fluid surrounding the solid core. Meanwhile, under certain conditions, truly fantastic phenomena are also possible. For example, the gravity of a more massive planet can potentially capture satellites from its smaller companion, while tidal forces may destroy them to form vast asteroid streams. In addition, the mutual gravitational pull of the 2 planets distorts their orbits, altering eccentricity and other parameters. Because of this, the entire system behaves chaotically and unpredictably, and its evolution cannot be predicted over any extended period. Modeling shows a 91% probability that the 2 planets will collide with each other over the next 70 million years, producing hundreds of thousands of pieces of debris which will disperse throughout the planetary system, thereby further increasing the chaos within it. Such tremendous cataclysms may have occurred more than once in the following system. 434 light-years from Earth. A surprising object, informally called Super Saturn, is located 4 away from a young sun-like star. It is a brown dwarf or a large gas giant, 20 times as heavy as Jupiter. Observations show it to be a young planet, about 15–16 million years old, which is still forming. Most of its atmosphere consists of hydrogen and helium, with a massive metallic core in its depths. This object is spun by a system of rings, like Saturn's, but much larger. The transit method revealed at least 37 distinct rings, with the largest one's outer radius measuring about 0.60. This is comparable to the size of Venus's orbit and about 640 times the radius of Saturn's rings. According to calculations, The total mass of the circumplanetary disk is bigger than the mass of the Earth, and its behavior manifests signs of randomness. Mathematical modeling shows that such structures are not stable and gradually disintegrate. Some of the objects make them lose up velocity and fall to the central planet, while others, on the contrary, accelerate and leave the disk forever. However, this process is greatly extended in time and may take several 100 million years. Also, a large rupture with a radius of about 0.40 is detected in the system of rings, which is considered indirect evidence of the existence of an exosatellite in this region, about 80% the mass of the Earth. According to current understanding of the physics of space body, it is the kind of object capable of clearing its orbit of small debris, forming a wide rupture in the ring structure. In addition, observations suggest the presence of at least 2 more celestial bodies, with a mass of about 30% that of the Earth and located at a distance of about 0.250 from the center of the brown dwarf. Just like it is the case with the large planets known to us, it can be assumed that a total of several hundred exosatellites, including some quite massive ones, may be located within the gravitational influence of the central object. A simulation of such a system, including radiation from a parent star, heat flow from a giant planet, and tidal influences, shows that the temperature of the celestial bodies making it up could approach comfortable values. One can only imagine how enchanting the night sky would be from the surface of such an exosatellite. At this distance, the brown dwarf occupies 70 times as much space in the sky as the full moon, and its soft glow can dispel the darkness and turn the night into a misty twilight. Instead of the star-spangled canopy, the planet's sky is crisscrossed by vast swaths of light from horizon to horizon. At the same time, the tidal forces of a nearby massive body could provoke multiple eruptions on the satellite's surface, and its hypothetical ocean could slam the land with giant waves. The width of a tidal zone under such conditions could reach hundreds of kilometers, making it a unique climatic zone, something like a cross between land and the ocean floor. Still, it should be mentioned that such structures tend to be unstable and change their appearance quite quickly, beyond recognition. At present, it is difficult to say how much longer we will be able to admire the giant rings and what they will look like in millions of years. Deep space is full of mysterious and surprising objects. They appear to us in the form of many photographs and vast amounts of information, gradually revealing their secrets to the pervasive human curiosity. Meanwhile, each discovery raises new questions, which means that the learning process is quite endless, and each of your likes helps us create new and exciting videos about space and faraway worlds. And let's keep in touch.